So, you're in your shop, and you get an order for a part that's only about 200 thousandths thick. So, you gotta make it out of a plate, something kind of like this, right? Because this is a 1/4 inch plate, which will need to be face down. How are you gonna hang on to this? Most shops are equipped with vices similar to this, and this vise will hold this part. If you move the jaws to the outside, you can place it here and tighten up on it. But what happens when you tighten up on it? What happens when you start facing it? It's probably going to bow, right? What if you get an order for a part that is something kind of like this guy? This is thin wall. The dimensions aren't that bad. It should be pretty easy to make. So you get your stock all squared up and you start cutting on it, and eventually you reach a point where you're going to have to hold it something kind of like this. Well, again, what happens when you tighten down on this part so that you can do these operations on it? Again, probably going to bow up, right? This is a simple solution to all these problems. It is a vacuum fixture plate. In the case of thin material, we don't have to worry about bowing because it's completely supported from underneath. The only thing holding the part down is the pressure of the atmosphere. It uses a pneumatic vacuum pump, and we have a gauge here. The gauge is kind of just for convenience to see that we are in fact achieving vacuum. This particular pump will pull about 25 inches of mercury, which if you convert to PSI, that's about 13.1 PSI. And if you do the math on that, a 1 square foot piece of material, 144 square inches, that's right around 1,800 pounds of downward force on the material. Now, this vacuum plate fixture, it's not unique in the manufacturing world. As a matter of fact, a few companies make them. One in particular, Mighty Bite, makes them. They have several different options available. They're in a bit of a different configuration than this, but they are quite pricey. They have one in particular that is made specifically for doing like pallet swaps, and that one I think I found on Amazon for about $3,400. This unit I made here in the shop in my Tormach CNC mill for far less than $1,000. I ordered the vacuum pump for I think it was about 60 bucks, and then the rest of these parts, the stainless steel line, the Yorlock fittings, and all the little NPT fittings, I think here totaled about 80 bucks. A piece of aluminum was a couple $100, and then you throw in a bit more for hardware, and again, maybe $500 I spent on this thing. The seal that I use is actually latex medical tubing with a 1/8 inch OD. You can get these in boxes of 100 feet for under $100. And it's pretty easy to set up and use. I'll show you. So your first step in setting this up is you have to figure out where you're going to set up your seal on the actual plate. The vacuum porthole is actually this hole right here in the middle. There's a cross hole obviously that goes to the front. So step one is to take the material that you're going to be cutting and lay it down onto the vacuum fixture plate. It doesn't necessarily have to be straight or anything because you're going to be cutting your part out from kind of the middle of it, right? So like let's say that we had a part that filled this whole plate. It still wouldn't quite matter that it's straight because we're going to leave some around the edges when we're cutting the material out. So what you do is you take your part, you lay it on here, you get it, relatively straight, eyeball straight is fine. And then you take a marker, and you're going to mark all the way around where the part lays. After that, you're going to remove the part from the fixture, and then you're going to lay out your sealing tube. The way that you want to lay out this tube is in such a way that you don't have any bare ends contacting each other. So you need to make a little box kind of in one area where you have them kind of meet up in these corners where they're smashed together, or they will be smashed together anyways after you apply vacuum. You just lay that line out inside of your pre-marked line from where you marked off on your material. Then you're going to place your material over the seal. You're going to make sure that it's decently centered and decently straight. Once again, eyeball straight is fine. Once you have the plate set on top of the seal, then you can go ahead and just apply vacuum. So the way you can apply vacuum is you just get your shop air and you plug it in. And then we see here we're pulling about roughly 23 inches of vacuum. You can do better than this if you set up your seal a little bit better, but this is decent. 23 inches of vacuum is plenty of holding power. You can see here, I'll go ahead and pull on it, and the plate doesn't move. So in the case of the part that's 200 thousandths inch thick, and that's just an example, you can actually go way thinner or way thicker than that. What you could do here is you could go ahead and face off this entire plate and then flip it over and then face off the other side down to thickness, and then you can start your machining process. The caveat here is that using the vacuum plate will not make your part flat. Any bend that is in the part when it's just sitting out is going to be retained for the most part once you're done with the part. So you have to start with a pretty flat piece already. The vacuum plate will, however, ensure that the parts that come off of it are very parallel. Next, I want to talk about the machining strategy that you would use while machining a part on the vacuum fixture plate. So when you're using a vacuum fixture plate like this, you definitely don't want to go deep enough to start cutting into the plate, because that is, well, it's going to destroy your plate, right? You have to be able to use this again later on. So typically what we would do is we would program 0 from the bottom of the plate. So in your G-code program, you would set, or your G54, you would set your G54 Z0 at the top of this plate, and then in your program, you would never program any tool below 0. So if you look at a part like this, we see that it's got windows through it, and there's some slots and things like that. So something like this, what we would typically do is you would program from the bottom up, but in order to get this window out and some of these features and cut this out of the overall plate, what you would do is you would use a ramping strategy around the edges, around the edge of the part and around the edge of this inside window and these little slots here. But what you want to do is you want to leave about 3 thousandths of material. The 3 thousandths of material left behind will keep the seal while you're working on the part. Once your machining operations are done and you get the part out of the machine, you can literally just cut out the pieces with an X-Acto knife, and then either you can run a second op. This part is not really conducive to second op for deburring, so what we would do in that case is we would just hand deburr. But some parts that you run in the vacuum plate are conducive to second ops. You can flip the part over, you can run a deburr, whatever you got to do to get the part done. So again, you know, this type of setup, they are available for sale. Like I said, I've seen them. You know, Mighty Bite makes them. Uh, they're pretty pricey, and I didn't want to pay that price, so I just made this one myself. Uh, this is not even actually like entirely my design. I actually got this idea from a shop that I worked at. It's the only other shop that I've seen with a vacuum plate in it. But the owner of the shop made his own plate, like I did, um, and he was kind enough to share the DXF file with me for these little pockets. And the only thing that I added to this is threaded holes in each one of the islands here. This will allow me to set up stops or use clamps or other things of that nature if I ever need to. I think that, you know, if I wanted to palletize something on this, I would just set up some stops on here and then machine my pallets that way, and that way I would have something that I could just pick up and put down for longer runs. Next, I'll talk about things that I think I could have done better. Namely, the first thing that I think I could have done better is I actually kind of need a quick disconnect here. It would be nice to be able to disconnect the vacuum pump from the rest of the system, just in case I ever get any trash down the vacuum porthole. If I do get trash down the vacuum porthole as it stands now, I have to actually disassemble the system to blow it out. If I had a way to quick disconnect it, then I would just be able to quick disconnect it and blow it out, and it'd be no problem. The next thing I think I could have done better is used some kind of air separator somewhere on this line. I really don't have the space for it in here. I mean, this is a Tormach 1100 MX, and it's pretty small. But what the air separator would have done is, anytime coolant got sucked into the vacuum porthole, it would have just separated the coolant from the air coming into the vacuum. As it stands now, if coolant gets down there, it's not really a big deal. It's not going to hurt the vacuum or anything, but it will mist out of the muffler of the vacuum pump here, which can get irritating. Anyways, I hope you enjoyed the video. If you need any parts made or anything, or you want help maybe making your own vacuum plate, you can go ahead and send me an email. I'll leave a link to my website in the description. Alright, thanks. Have a good one.